my voice will hold, but I had a bit of a cough over the last couple of days. So if you see me disappear for a second, that's why. But yeah, as Suzanne said, and thank you so much for the introduction, my name is Sofia Calzavara, and I head the Subnational Statistics Development and Dissemination team, which is based in the Subnational Statistics and Analysis Division in ONS. And today I'm here to present on the Explore Local Statistics beta service, which we launched at the end of March this year. And I'm also joined by my colleague Will Haste, who will be instead presenting some work we did on clustering UK local authorities. So what is exactly Explore Local Statistics? So ELS is now the beta version of our public-facing digital dissemination service. To find out more about local authorities across the UK. When we think about ELS, the target user groups that we work for are analysts and policymakers in local government, very much as yourselves, but also central government, as well as members of the general public who might be interested to understand more about their local areas. It's also helpful to think about 4 main user needs when thinking about ELS, which are finding, visualizing, comparing, and downloading a wide range of statistics in one place. The service, as I mentioned, is now live. It was launched at the end of March, and Will might be able to post a link in the chat now, so you can then have a look. So it's all publicly available. Feel free to share it with your stakeholders and spread the word as much as you can. I also wanted to mention that the development of Explore Local Statistics is part of a 3-year project funded by the Ministry of Housing, Communities and Local Government. And as part of the project, we are also delivering other deliverables such as new granular statistics, for example, GVA at LSOA level, that was published a couple of years ago and then republished this year, but also more innovative analysis, including the clustering analysis that will be presenting. And if you are interested to learn more about this project, we have recently published the monitoring and evaluation report covering the 2nd year of the project. So the link is now in the chat. So just going back a couple of steps before thinking about the launch of Explore Local Statistics. The vision for the development of this service really started back in December 2021, when it was announced in the Government Statistical Services Subnational Data Strategy. So for those of you who are not familiar with the strategy provides a framework to guide government analysts in producing and disseminating more timely, granular, and harmonized subnational statistics. The strategy in particular identifies 3 overarching ambitions. The first ambition is to produce more timely, granular, and harmonized subnational statistics, so aiming for subnational by default. The second ambition focuses on building capability and capacity for improving subnational statistics and analysis, for example, by improving the way in which we share data, methods, and expertise. And actually, this webinar is a very good example of this second ambition. And the third ambition is to improve the dissemination of subnational statistics so that users can draw more easily insights from our outputs. And if you think about these 3 ambitions together, they form a bit all of the basis for the Explore Local Statistics service. I have had, to be honest, the privilege to lead our work on this project since the very beginning, so since the launch of the strategy. But it's been quite a long process so far. We've been on quite of a journey with the project team. In fact, in February 2022, we published the alpha prototype, which is the Subnational Indicators Explorer, which you might be familiar with. And we have updated this Explorer approximately once every quarter over the last couple of years. And the latest release that was published in March and included 50 indicators. So effectively, across these 2 years, we have doubled the number of indicators that include in this release. It's worth mentioning that we are going to retire this product, or at least at the moment we are not updating it anymore, because we feel like all of the data and the functionality that was delivered through the prototype are now fulfilled by the beta service. But it was a very important step in our journey, so I did wanted to mention it. Then about a year ago, we launched our first geography-focused journey on the ONS website, which at the time was called Find Facts and Figures. This was a very much a minimum viable product of our beta service, and brought together existing products that allow users to explore local data for specific areas, such as census maps, build a custom area profile, the Subnational Indicators Explorer, and a few other products. Then, in March this year, as I mentioned, after a couple of years of development and many rounds of user research, we have launched Explore Local Statistics. And in developing our service, it's worth mentioning that we are following the principles outlined by the Government Digital Service, and we are delivering it according to Agile framework. So for this reason, when you hear me referring to alpha and beta, that's the terminology that comes from the GDS framework. Fantastic. So, apologies. I will now swap to another screen to give you a bit of a quick demo on Explore Local Statistics. But before I do that, I do want to emphasize that this is still a beta service. So as such, we are still continuing to develop and improve on the service. So if you have any feedback, we really encourage you to come back to us, to contact us, and also to share the service with your stakeholders and let them know that they can come back to us with feedback and comments. On the top of the page, you will see there's also a feedback form, and obviously you're very welcome to contact us directly. So let me just swap to the other screen. Okay. Can you all see the right screen now? Will, can you just tell me whether you can see it?
Yes. Yeah, all good.
Fantastic, because I lost you also, I can't see you. Lovely. So here we are on our lovely Explore Local Statistics page. As I mentioned, here there is a bit of a feedback button you can use to leave your feedback or get in touch directly with us. I will start the demo by talking about how to navigate the service. So the Explore Local Statistics homepage provides users with two options. You can search for an area by typing in the Find an Area box, or you can browse the different indicators available, grouped by topic. So for example, if we start by typing Swansea, and then clicking on the magnifying lens, this takes me to the start of the Swansea area journey. If I scroll down this page, I can see a variety of products that are available to look at data for Swansea. But I also have this blue tile here and this blue tile here on the right, which bring us to the new Explore Local Statistics beta journey. So if we click on Explore Local Indicators, and wait for a second for it to load. This page provides me with a rich default view of the data available for the area I have selected, and a lot of functionality that I need to view and create different visualizations. So as you can see, similarly to the Subnational Indicators Explorer, the indicators are presented vertically and are grouped by topics that you can select here on the left. So if we focus, for example, on Swansea labour market data, for each indicator we have two visual elements. The first on the left shows the distribution of areas using the median absolute deviation. And each circle represents a local authority, and areas with low values are on the left, while areas with high values are on the right. And Swansea, or the area you have selected, is then represented by the blue circle. And we also have a comparison, which in this case is the median of all local authorities available in the distribution, and it's highlighted in purple. So if I want to change the comparator, I can go to these change areas And for example, I can decide to compare against only the median of all local authorities in Wales. And for example, restrict the areas I can see on the jitter plot on just the other local authorities in Wales. And I can add a couple of other areas to compare against. Okay, so I had Pembrokeshire and Flintshire. Fantastic. And now you can see the number of local authorities displayed have dropped to just the local authorities in Wales. The new median which is utilized is the median from local authorities in Wales, and I can also see the other two local authorities highlighted in a different color.
So Pia, I think that I think it's frozen from my side. I'm not sure about anyone else's.
Oh, fantastic. It's not frozen on my side. Can anyone else give feedback on whether you can see correctly? Susan, maybe do you know if you could see everything?
I think so, yes.
Can you see 4 colored dots here?
And we're getting comments here as well. Yes, we can see 4 colored dots, and we're getting comments in the chat bar that it is correct as well.
Sorry, must have been frozen on my side. Sorry about that, Samir.
No, that's fine. Better to check rather than me going on talking about things that don't appear on the screen. Thank you, Will, for checking. Lovely. So another thing I wanted to add was that if we go back to options, there's also the option to display confidence intervals, and I think this is a feature that I'm particularly fond of because obviously working with data at lower levels of geography has more uncertainty than higher levels geography. So being able to appropriately showcase uncertainty I think helps to also build the confidence in the data, or at least help users to navigate the uncertainty of the data. So you can see how you can choose to add confidence intervals. The final thing I wanted to note on this section is that I can click on this info button here to display a lot of additional information on the original data source. Which I think is particularly important, and you can also go back to the original data source by clicking on the links provided. Fantastic. So let me see the next thing I wanted to show you. Yes, so if we actually scroll down the page or select an indicator, here you can see we have a few different options to create charts. So obviously at the moment it looks like there are a lot of lines there. So if we just highlight the same areas that we wanted to highlight earlier, and then display only local authorities in Wales. Now you can see you have a nice line chart, or you can also have a bar chart or visualize the data on a map. And again, on the line chart and bar chart in particular, you can also display confidence intervals clicking on the option button. And all of these charts, as you can see, can be downloaded in PNG. The data for them in particular can be downloaded, or you can embed it in your own website. So there are a few different ways in which you can reuse these charts and save you the time from having to build them yourself. Finally, something I wanted to mention on this area, but I won't say too much on this because we'll tell you a lot more on the clustering later. We have this similar areas section, in which areas that are statistically similar to the one you have chosen are displayed according to a few different clustering methods, in particular a general method. And then you can also choose an economic model, a demographic one, and health and connectivity model. And then you can have a read about the particular cluster, the area you've chosen belongs, and also see all of the other areas that belong to the same cluster. Finally, at the bottom of the page, I think this is a particularly important feature, though might not be as visible because it's at the bottom. You also have a possibility to download a relatively big file with all of the more than 60 indicators we currently have on the service for all of the possible areas. So if you are interested to redo some of your analysis and, for example, you want to download the data quickly rather than going back to the original data sources, you could do that. Although obviously for completeness, I would always advise you to go back to the original data sources by the data producers, so you can also have a look at all of the methodology for the individual data sources you're interested in. Lovely. So I will now go back at the start of our journey to show you the second journey. Oh, sorry, I went too back. To show you the second journey, which you can access via the Explore indicators. So if we select, for example, gross median weekly pay, again, similarly to the previous page, you have the possibility to reuse and explore a few different visualizations. So we have a map, a line chart, a bar chart, and also the data as a table. But what you can do here, so basically here we are changing the focus from the previous journey where you choose an area and then look at all of the different indicators for that particular area. Here you're choosing a particular indicator and you look at that indicator across multiple areas. For this reason, we have also included the flexibility for the data sets that allow us to do that, to change the level of geography you're looking at the data for, and also change the year you want the data for. Again, you can highlight different areas and select different comparators. And you can also find some further information about how to interpret the particular data set or some notes on the original data source. I think that is everything I wanted to show you on here. So I will just stop sharing this screen and go back to my presentation. Sorry, a lot of swapping around. Coming through now. Just going to quickly navigate to where we were. Fantastic. So as you can see, a lot of new functionality is available on the Explore Local Statistics beta service compared to the previous alpha prototype. But as I mentioned, it is a beta service, so there is a lot we can do to improve the service, and that's why we very much welcome feedback and are always very happy to run this sort of webinars to get your views on how you can use or you're going to use our service. So what are our priorities next? So really, I guess, three main priorities. So the first one is around promoting and raising awareness among our target users. This webinar is an example of that, because obviously we have made a lot of investment on building this service and we want to make sure it brings value to as many users as possible. The second priority for us at the moment is to conduct user research on the live service, and this helps us to improve and iterate on the existing functionalities and decide what new functionalities to build in the future. And finally, we really want to add more data sets to the service. In particular, one of our priorities is to fill gaps for datasets that sometimes are only available for England. So this quarter in particular, we've worked a lot to fill some gaps of datasets and find datasets that are comparable enough for the default administrations to be presented on the service. They are presented in a slightly different way, in the sense that if they are not fully comparable, they are in a separate data set rather than being part of the one data set. But we still think it is much more valuable to have them there rather than not having them. And finally, as part of this process of adding new data sets, we are also working on improving the resilience of the data pipelines through which we feed the data onto the service. Because as you can see, today I've given you a presentation primarily focused on the front end, so how you see the service, how you can interact on the service, but there is a lot of work going on behind the scenes to keep the data and the service running. So now I'll hand over to Will so that he can talk you through the local authorities clustering.
Thanks, Sophia, and thank you everyone for taking time out of your afternoon to come to the talk. Just as a quick bit of housekeeping before, my internet's acting up a little bit today as my rude interruption of Sophia during her demonstration shows. So if I freeze, it will resolve itself very quickly. It's a slightly ongoing problem, but I might freeze. And if that's the case, Sophia, could you just mention it to me? Because I can typically see everyone and my connection stays fine, but it's me who freezes on my end. But anyway, that boring stuff out of the way. My name's Will, and I work within Sophia's team in the subnational methods for dissemination team. And I led the clustering work that Sophia has just demonstrated some of the results of. Excellent. So firstly, I'm going to go through a little bit of an introduction of what K-means clustering is, why we chose it for our sort of analytical pieces, and some of the results of our most recent clustering output. So just a little bit of history before we get into the methodology. My team's been working on clustering for about 2.5 years at this point, and we've released 2 outputs, one of which was last year and was a standalone article looking at how different local authorities within England perform and how similarly they perform against the levelling up metric specifically. In our next phase of analysis, which is the one that's presented on the Explore Local Statistics platform, we focused on UK-wide data and a more holistic view, a wide-ranging view of similarity, rather than just focusing on the specific metrics outlined in the levelling up white paper. Now, we started this clustering work because basically we had a lot of access to lots of subnational local authority level data, and we're a team that specialises in some more methodologically complex outputs. So we did a bit of user research about what people would like to see as an output from that local authority data. And one of the needs that came up quite a lot in that research was focusing specifically on looking at boosting sample sizes, creating control groups, and generally creating similar groups of local authorities that could be used for analysis. Now, this would often be done looking at, say, policy interventions, so looking at sort of different policies that have worked in a specific area, subnational area, and then you can look at how similar your area is to that and whether or not which of a suite of policies would work in that case. And then more generally, it's been used just to boost sample sizes. I mean, I know if any of you, a lot of you presumably work in subnational data, and one of the big problems that we have is getting reliable data at that lower geography. A lot of the time, the sort of fix on that is to use regional or higher geographies to sort of try and create dummy results. But those groupings are basically mainly based off geographical similarity, and we thought that we could create a more holistic and usable version of similarity, and bigger groups that can be used for analysis. So now that we had that end goal, we decided on our method, and we chose K-means as our clustering method. Now, this is effectively because K-means is one of the simpler and more sort of easily explainable clustering techniques, and there was no point of us creating these outputs if no one was going to use them. So that was part of our thinking, and also largely clustering's a bit of an inexact science in general, so a lot of the work that we did was sort of outside of the specific technique that we used in sort of modifying the model, which I'll go through in a little bit. So yeah, that's why K-means. And K-means is, for anyone who's not aware, an unsupervised machine learning technique which identifies and groups similar data points within a data set together. Now, if you want to follow the nice flowchart down the right side of this slide, we can see, which is a visualization of the process that I'm about to explain to you on how the k-means algorithm works. And it basically generates a number of random points to start with. These are a k number, that's what the k is. So it's the number of means, and each data point within a sort of multi-dimensional data set is then assigned to its closest cluster center, and the total distances between cluster center and point are then stored. These centroid points, it works iteratively from this point, so the centroid points are updated to be central within each cluster, and then the distances are recalculated, and this process is repeated until the process has met inertia and the centroid points no longer change. So we used Python to do our coding, and specifically the sklearn package in our analysis. We published all of the code that we used for this project on our public GitHub, so you can go and use that and look at it. Sophia's kindly going to drop a link in the chat, I think, to that. And yeah, you can, and there's also one in the presentation, and you can follow our methods through that perspective, and also use our clustering code on your own data sets if it's in the correct format, which is all specified in the guidance to that code. The sklearn package is brilliant for clustering, and it allows you to change a lot of the sort of more physical parameters which we used within our coding system. One of them was the number of clusters that you want to produce. So we maximized our number of, so we wanted to maximize the silhouette scores, which I'll go into in a little bit, but basically a measure of cluster distinctness, and maximize our models to see which was the most sort of maximal result between 4 and 15 clusters. Now, we chose that number of clusters because past 15, we wouldn't really be solving the issues with sample sizes, because we'd have lots of small clusters there. And lower than 4 clusters, we start getting into the territory where we experimented using 2 or 3 clusters. And basically what the sort of model did in that stage was to create a cluster which was London and then the rest of the UK, because London's so different in a lot of our metrics. Obviously, that's not very useful for subnational analysis, so we had to raise the minimum number of clusters to sort of counteract that problem. And the sklearn package also lets you, we did things like run the model 10,000 times with 10,000 different centroid points. That means that we can be sure that our results are the most stable. And at the same time, you're able to set the number of iterations it goes through before it's meant to go through, before it reaches, before the model sort of stops and it's reached the inertia. And we chose 300 for that figure. Okay. So now I've gone through a little bit of an introduction on k-means and how we coded it. We're going to switch and focus a bit on the data that we wanted to include. Now, one important thing about k-means, which we'll come on to in the next slide as well, is that it can't deal with missing data. So whenever there was missing data for any local authority, that local authority had to be excluded from our analysis. So our main sort of priority when we were looking for new data to include in this model were data completeness, so a figure for every local authority in the UK, and also comparability. So I know a lot of you working with Welsh data will have come up against the same pitfalls as we did, trying to find, say, comparable health data for England and Wales, and it's a bit of a minefield. So we work quite extensively with the devolved administrations to source that. But the majority, I'd say about half to 2/3 of our data came straight from the ONS ELS platform, which was handy. Yeah. So once we'd identified our suite of possible data, I think we had about 45 data sets initially. We ran them through a number of checks to make sure that they were comparable at the UK level and just appropriate for inclusion in our models. So with the UK level data, when it was UK single source, we didn't do any further analysis on it and we included it into our model. But where we had to source individual data for the nations of the UK, say one example of this would be GVA, I think, that we used, we had to find different, sort of different sources for it across the UK. And when we had those sources, we had the discussions to check they were methodologically comparable. And when it was confirmed that they were, we also ran them through distribution checks of our own, just to double check that the sort of means and the sort of skew of the data looked similar across all of the nations. Once the data had passed that test, we also looked at its sort of interactions with the other data sources we were including. So we ran correlation coefficients, a big correlation matrix across all of our metrics. They're two words hard to say in close succession, but and our correlation matrix we sort of used as a bit of an advisory tool. Now, k-means clustering can very easily deal with correlated data. It's not going to cause a big issue with the model, but because of the nature of very correlated data, if it does sort of weight the model towards those variables, because if you've got two variables within a model that have almost identical results, the effect of those two variables are going to be doubled, and the models will be weighted towards variables we didn't necessarily want them to be weighted towards. So we looked at the correlated data, and two examples are shown at the bottom of the screen. We decided to exclude country of birth and the feeling that life is worthwhile from our models because they were very correlated with other very similar metrics, and we didn't necessarily want to have, say, 4 well-being metrics, but 3 health metrics within the model. We tried to control that sort of work. When we were looking at to make sure that we were right to exclude these variables, once we'd identified the ones that we wanted to exclude, we ran a principal component analysis on them, which basically looks at how much of the variance is explained by different sort of components within a selection of variables. And when that tailed off quite quickly and a lot of the variance could be explained by 1 or 2 components, we saw that it wouldn't impact the models too greatly if we removed those variables, because the trends within those variables were available in other variables that were going to be included in the model. Okay. So once we'd identified this data set and we'd done all of the checks to filter it down to data that we were sure that we only wanted to include, we had a second problem, and that was that the data that we included wasn't all from the same year and wasn't all produced to the same local authority boundaries. So we had data between 2019 and 2023 in the model. And for anyone who wasn't aware, there were a lot of smaller local authorities within England that merged to form new unitary authorities over that time period. That caused an issue within our model, as you can see on the visualizations on the right, with the top right that was our first output from our models, and obviously it's not quite geographically accurate. Last time I checked, Scotland wasn't an island and Bristol wasn't flooded. So we knew we had to solve those issues, and we came up with a weighted imputation method where basically we'd take the old local authority values, and then we'd weight them by a relevant variable being population, say, or area, or whatever it would be for that specific variable we were looking at, and we basically weighted those variables for all of the local authorities forming the new local authorities, added them up and came up with an estimate of what the new local authority value would be. Another issue that we had with our initial outputs was that there were quite a lot of instances of very small groups of local authorities forming the top cluster within variables within our different models. So that we looked into that, and that was caused by extreme values within some of the variables. So we had to come up with a way of dealing with these extreme values so that they weren't causing clusters of 1, 2, or 3 local authorities to form, because obviously for the purpose of things like control group analysis or boosting sample sizes, a small cluster of 3 central London local authorities isn't going to add too much insight to people. So we tested a number of methods to try and deal with these, this issue, and we had they were Windsorization, inverse hyperbolic sine transformations, and logarithmic transformations. So we tested those 3 transformations on the data to see if it dealt with these small clusters, and also to see what its impact on the silhouette scores were. Now, silhouette scores are a measure of how distinct a cluster is, and it's a bit like a correlation. It goes from -1, which is they completely overlap, to 1, which is they're completely distinct from each other. And we use that as a metric to look at the success of our data transformation and whether or not it was producing results of a similar quality. The short story is that the bottom 2 transformations we had there, being the inverse hyperbolic sine and the logarithmic transformations, sort of dealt with the small local authority groups issue a little bit, but not as well as the Windsorization, and also that produced far worse silhouette scores than the Windsorization, which actually improved the silhouette scores from the original model. For anyone who's not aware, Windsorizing is a statistical technique where you basically take the ends off the distribution of a set of data. So in our case, we chose the first and the 99th percentile as the sort of cutoff values. And basically any value that's below the first percentile is set to the value of the first percentile, and any value that's above the 99th percentile was set to the value of the 99th percentile. That meant that only 3 or 4 local authorities were changing at each end for every model, so there wasn't too much change within the data, but we were curbing those extreme values while maintaining those values as very high, so those local authorities were still falling into sort of local authorities which had similar results to them, but these individual variables weren't having such a high impact that it was dictating that one local authority was completely different to all of the other local authorities, which is what happened with our connectivity model, where one of the clusters was just City of London because it's got a hugely higher CO2 emission per kilometre value than anywhere else. So but yeah, that is the general process that we went through to try and refine our outputs once we got our initial outputs from the data I highlighted previously. So that's basically everything I'm going to go through on the methodological side. It's quite there's some more stuff we could go into, but it's quite heavy for a Thursday afternoon. So I think we're going to move on to just briefly talk through some of the clustering outputs now. Now, briefly, so what we did was we produced 5 models in the end, as Sophia demonstrated with the ELS tool. These were the global model, which basically included every variable that we deemed to be suitable for inclusion, and it's meant to be used as this is sort of the one way that you'd look at for the most nuanced version of similarity. So if you were looking to pick out a local authority that was most similar to yours across all metrics, the global model would be where you went. And we also ran what we called 4 topic level models. So that was where we looked at our data and we tried to look for commonalities and sort of themes that we could group it into, and then run individual clustering models on that. So you could say, which areas are most economically similar to mine, for instance. And these 4 topic level models were our economic model, our demographic model, which basically included all census data that we could get our hands on. We also had a health and wellbeing model and a connectivity and sustainability model. But the one that's pictured on the screen right now, this is the global overall model. And just to sort of briefly speak through some of the trends on this, we have cluster A here, which is the blue cluster, which was similar. This is the global model, as I said, but it was similar across all models. This cluster was basically the same across all of them because rural areas are very different to urban areas in this country. And the local authorities that were characteristically in this cluster had older residents. They were predominantly white and had the highest health and well-being figures out of compared to the other local authorities. So any of us who live in cities, apparently we're not living the same sort of life in terms of well-being as our rural counterparts, and I say that as someone who's in London as we speak. We've also got the cluster B there, which was basically a commuter belt around major urban centres. So these were generally characterised by high employment rates, high life expectancy, fewer smokers, and sort of low children and relative poverty. So these were quite affluent areas we were looking at. There was then cluster C, which had low GVA and low life expectancy and high manufacturing employment and employment in other sort of industrial trades. Now this is quite clearly, if you look at it, we term these the sort of current and past industrial heartlands of the UK when we were looking at it. So it's not the most distinct in terms of colours, I apologise, but you'll see that there's a large band of South Wales that falls into this green cluster. It also goes across the Midlands, and there's the industrial belt of Scotland there as well. And we also had, and then we have this final cluster, which was urban centres. So it was interesting actually to see. It was vast majority was London, but there were some areas in Leicester, Manchester, and also Birmingham that fell into this cluster. So that was quite interesting to see which other areas in the UK had similarities to London. where now, because of obviously, because we're talking to Data Cymru, I'd be negligent not to go into some of the Wales specific results within this. So you can see within the global model here that Wales pretty much exclusively fell within cluster A and cluster C in our global model. And that was roughly split between rural areas and sort of and South Wales industrial areas. A few sort of interesting examples within that would be Pembrokeshire, which Sophia highlighted earlier. If you're noticing some beautifully planned symmetry there, which is one of our classic. It was possibly one of the most classic rural areas when you look across all of the models. It was in all of the rural clusters, and it had particularly high well-being scores, which anyone who lives in Pembrokeshire will sort of. I know Pembrokeshire quite well, and I think it's a lovely area, so I completely understand that. An area that was a little bit different was Flintshire, and that was a classic sort of rural constituency by a lot of the metrics apparently, but in terms of the economic model, it felt quite, and the connectivity model, it had more of a similarity to an industrial area than a rural area. So that was one of the rare local authorities that was sort of split between our rural and some of our other clusters. And then finally, that we've got that band of South Wales local authorities that included Swansea, Port Talbot, Merthyr Tydfil, and a few others. And those local authorities were interesting because they were so similar across all of the models. That bank of 8 local authorities was in in each of the 5 was in the same cluster. And I think we can deduce from that, I don't know, that those areas are very, very similar to each other when compared to sort of the rest of the UK as a whole. They share a lot of similarities. So that's probably not surprising to a lot of people who work more directly with a lot of Welsh data than I do. But within our models, that level of consistency was quite surprising. Yeah, and I think that comes to pretty much the end of what I wanted to talk about. Just to say that we are doing some current work on future clustering. We're looking at different geography levels that we can cluster at, and also different data sets that we can include within our clustering model. So if anyone's got any commentary on that, or just wants to learn anything more about the methodology, please do give me I'm happy for my contact details to be shared. I'm not, or anything like that, or through our hosts. But yeah, was there a final thing? And I'm going to share in the chat now our data tables that came out with our work, and pass back to Sophia, who's going to briefly talk you through ONS Local. Thanks.
Thank you so much, Will. Right. So as I mentioned, we're part of the Subnational Statistics and Analysis Division, but we work very closely with a sister division of ours, which is ONS Local. So some of you might already be familiar with ONS Local, but I just thought it was a good opportunity to give you a bit an overview of what they do, in case you're not familiar with them. So let me just, right, so what is ONS Local? So it is an analytical advisory service that was established in 2022 that supports local government in accessing the data, statistics and analysis they need to make evidence-based decisions. So ONS Local comprises regional leads in each English region and devolved governments who are responsible for communicating with and collecting the user needs of their stakeholders. Obviously, ONS Local analysts do not work alone, and they draw on the support and resources across the wider ONS, but they really act as a bridge between the local government and the wider ONS subnational offering, which ELS is part of, obviously. There are 5 key pillars of the service, which are the analytical service, the data service, the network service, the strategic, and the building capability. So I won't go into too much of the detail of reading each of them, because I mean they are on the slide, and we will be sharing the slides later. But it's really a multifaceted service from that perspective. So how can ONS Local help you? So they can help you by building stronger relationships with local and regional stakeholders, understanding your stakeholders' needs, also through the lens of the help that ONS can give, Keep users informed of changes happening to our statistics, and I think this is a particularly important one, especially given all of the transformation work that is happening around the labour force survey. Make the best decisions regarding pausing or stopping outputs considering user needs, and really give a platform for the subnational work to be showcased. For example, through some webinars that ONS Local are running regularly. There are a number of other aspects of the service that I'm not going to cover right now. But yeah, if you are interested, do have a look at the slide. In particular, as far as Wales is concerned, the relationship that ONS Local has established with the devolved governments is slightly different from the relationship that has been established in the English regions, and this is to reflect the diversity of needs in the statistical system. So here you can see there has been a bit of a staged approach, building the relationship and establishing a front door to work with stakeholders in Wales. And again, I won't go too much into the detail, but we have a leading on our engagement with Wales, and I'm sure they will be happy to be contacted if you had any questions. In fact, this is a bit of an overview of all of the ways in which you can contact ONS Local. So the devolved liaison officer for Wales is Chanelin. Here is her email. There's also a generic ONS Local email that you can contact. I briefly mentioned about the webinars. So if you are interested about the webinars, please sign up to the ONS Local Presents webinars on Eventbrite. I will share the link as soon as I stop sharing the presentation. And yeah, I think that was everything from us. So thank you very much for listening. Here you can see my and Will's email in case you want to send us some questions afterwards. And yeah, it was a pleasure to be here. So back to Suzanne.
Thank you very much, Sophia, and thank you to Will as well. That was really comprehensive and really, really informative. So thank you very much both. And we're getting applauses. I say we on your coattails there, getting some applause, which is lovely. So obviously, if anybody does have a question, please enter that into the chat for either Sophia or Will. As is usually the case, I do have a question. It is quite specific, actually. So forgive me. It's for Will actually, because it was when we were talking about the clustering. And it was just, I don't know if you'll be able to answer this, I'm kind of looking for a high level answer, I guess. But do you mentioned that when you were using the K-means methodology, it doesn't like missing data, and therefore where that happened, you'd have to exclude an area from that calculation. Do you have an idea of how often that was happening, like the extent to which areas were having to be excluded? And I guess, were there any patterns in that? I'm just interested, I suppose.
So yeah, it's not just to clarify, it's sort of the data would be excluded if there was too much missingness. It wouldn't be areas being excluded, but it was happening quite often. It did change the type of data that we could include in the model. I mean, we weren't able to include as much survey-based data as we'd like, because there's obviously a lot of suppression and missingness at the lower tier local authority level for a lot of that. Where there was like a very small amount of data that wasn't available, but we did have, say, upper tier local authority data available, we did do a bit of backwards sort of imputation for some of our metrics. I mean, we used healthy life expectancy, and that's published at upper tier local authority level, but we sort of imputed down, and we did sort of include that for some of our metrics. So it wasn't a be all and end all if, say, 3 or 4 local authorities weren't in a data set. We normally found a way around that, but it was more the case where if it was some kind of data where you'd have 30 local authorities suppressed in the data, we had to exclude that sort of thing.
Thank you very much. We can give it another minute or so to see if any questions do appear in the chat. And if not, then we'll give everybody 5 minutes back.
I mean, obviously, particularly with the clustering, some of the concepts are a bit difficult to digest. So obviously, if you have any questions later, I'm sure maybe once you have taken a look at our article, did we post a link to the article, Will? Actually, maybe to the method article, we might want to post one. You're on mute, but I think you're saying yes.
Excellent. Well, there are no further questions. We've obviously given everybody exactly what they need, and they're all gone away and are having a look at the actual tool now, probably. So it just stands for me to say, again, thank you very much both for coming and speaking with us. Thank you to all of you who are attending, and we hope you get 5 minutes back, and we hope to see you at all our future sessions. So thank you very much, Sophia and Will.
Thank you so much for having us.
Thank you, everyone.
Have a great rest of your days. Bye.
Bye.